Hello friends, welcome back. Let us continue with the previous year gate questions. So this is the question they have asked in the year 2020 and they have asked it for the 2 months. Okay, now this problem is in the seepage pressure, right? Now water flows in the upward direction in the tank through 2.5 meter thick sand layer as shown in the figure. Find the void ratio and specific gravity of sand are 0.58 and 2.7 respectively. The sand is fully saturated. The unit weight of water is 10 kilonewton per meter square. What we have to find? We have to find the effective stress at point A. Right? Here if you can observe, the flow is happening in the upward direction. As the flow is happening in the upward direction, then we know that our effective stress will decreases. So what is the effective stress at point A? That is nothing but a effective weight. That means here we can say, so what is the submerged unit weight? That is gamma sat minus gamma W into whatever the Z value from here to here, 2.5 into 1 minus 1. So here it is 1.5. As the flow is in upward direction, the effective stress will decrease minus how much it will decrease? I into Z into gamma W. Z value we already know 1.5 from the top of the soil. What about I value here? What is the difference in water level? 1 point. It is directly given in the question divided by whatever the length of the specimen, 2.5. That's it. Substitute in this equation. So the effective stress at that point, that is nothing but a gamma saturation is given as how much? That's what also we have to need it, right? So did they given gamma saturation? No. So first we have to find out what is the gamma saturation. As the water is completely saturated, G plus C by 1 plus C. G value is given 2.7. Void ratio 0.58 given in the question. 1 plus C. 1 plus 0.58. They are asking us to consider unit weight as 10. So multiply by the 10. So if we solve this, we'll get this as around 20.75. That's it. Substitute in the equation. 20.75 gamma W saturation minus gamma W 10 into from to the point from top width 1.5 distance minus hydraulic gradient we are getting it as 1.2 by 2.5 into again what about the Z value 1.5 gamma W they are asking us to consider as 10. That's it. If you find out, you will get these values around 8.925 kilonewton per meter square. Right? Move on to the next question. That is what is given data. A sheet pile has an. So this question they have given in the year 2017, and they are given it for the 1 mark question. Now let us see what is in the question. A sheet pile has an embankment depth of 12 meter in a homogeneous soil stratum. The coefficient of permeability of soil is given 10 power minus 6 meters per second. Difference in water level between two sides of sheet pile is also given. Flow net is constructed with 5 flow lines and 11 number of equipotential lines. The quantity of seepage. Right? Now, if you see here, the water depth is given how much? H will be equal to 12 meter and coefficient of permeability is given how much? 10 power minus 6 meters per second. And what we have to find? What is the difference in between the water levels? That is what nothing but a 4 meter. So let us say that is what we are representing with the H. So how can I find the quantity of seepage? That is what nothing but a K into H into NF by ND. What about NF here? NF is nothing but a number of flow lines or flow channels. Always remember this is nothing but a number of flow channel. So they are given flow lines are 5. Then how many channels are there? Let us say this is flow line 1, 2, 3, 4, 5. That means in between two flow lines, one channel, second channel, third channel, and fourth channel. So if lines are given, channel is nothing but a minus 1. 5 flow lines minus 1, that is what? 4. Lines are given 11. What about number of equipotential drops? 11 minus 1, 10. So that will be equal to K value 10 power minus 6, H value 4, NF value 4, and ND value 10. Then if you solve this comes around 1.6 into 10 power minus 5 meter cube per second. But what we need the answer in centimeter cube per second per meter width. So if you convert this into centimeter cube per second, then you will get 1.6 centimeter cube per second. So that's what I'm telling you. Blindly, if you enter this answer, then your answer is wrong. Why? Because you have entered your answer in meter cube per second, but we have to enter in the centimeter cube per second. So always remember. Move on to the next. Let us read the question. The seepage occurring through an earthen dam is represented by flow net comprising of 10 equipotential drops. Here they are directly given 10 equipotential drops, 20 flow channels. The coefficient of permeability is also given. Head loss is also given. Just they are asking about the seepage. Again, the same formula, that is K into H into NF by ND. So this is the question they have asked in the 2016 for the 2 marks. See, all these are very similar questions will come if it all comes this. K values are given mm per minute. So let us convert into centimeter per minute. That implies 3 into 10 to the power of minus 1 into minute. If I convert into seconds, 60 into head loss is 5 meter. Convert into centimeter. That means into 100, 500 into flow channels. Number of flow channels is given as 20. Equipotential drops are given as 10. That's it. As your everything you are taking in centimeters, the final answer will get it as 500 centimeter cube per second per meter length of the beam. So the answer will enter it as a 500. Okay. Now in the next video, we'll see some more previous year questions. Thank you.